So for this problem, we are given two cylinders shown in figure, having its indicated width and dimension. So assuming smooth contact on the surface, we are tasked to determine the reaction at B and the reaction at A. So to do so, we first have to construct our free body diagram. For the bigger cylinder, we have the reaction due to the normal surface, that is the reaction at A, and the reaction at B. And we have the reaction due to the interaction between the two cylinders, that is, we call it reaction C. And the weight of the cylinder is equal to 400 kilonewtons. Now we have three unknowns, and we only have two available equations for equilibrium, that is summation for force x, and summation force y. We cannot use moment, that is because all the forces are concurrent at the center. So, since we cannot solve directly for the variables, we can make use of the other free body diagram for the smaller cylinder. We have the reaction at C. Oh wait, this is on the bottom. And we have the reaction due to the surface, we call the reaction D. And the weight of the cylinder is equal to 200 kilonewtons. Now we have two unknowns and two available equations for equilibrium. So we can, we first have to identify for the angle theta. And to do so, we make use of the geometry of the figure. So let's do some geometrical analysis. Knowing that the radius of the larger cylinder is 2 meters and the radius of the smaller cylinder is 1 meter, if we connect the center to center distance of the two cylinders, we are given the length of 2 plus 1, that is 3 meters. And we can construct a right triangle to be able to determine the angle theta here. So what is left for us is to solve the value for the horizontal distance. That is equal to 5.60 minus the radius of the bigger cylinder, that is 2 meters, minus this radius of the smaller cylinder, that is 1 meter. Therefore, the length of this distance, horizontal distance of the triangle, that is equal to 5.6 minus 2 minus 1 meter. That is equal to 2.60 meters. Now we can solve for theta using the cosine function. That is equal to adjacent 2.6 divided by the hypotenuse 3. So theta is equal to r cos of 2.6 over 3. So theta is equal to that is 29.93 degrees. Let's copy that to our free body diagram. And this angle here is equal to 29.93 degrees. Now that we have the value for the angle theta, we can now solve for the reactions. So let's begin by analyzing the free body diagram of the smaller cylinder, since it has only two unknowns. Therefore, we can use the equations for equilibrium, that is summation force x and summation force y. So taking summation force x equal to 0, we have RC cosine of 29.93 degrees minus RD equal to 0. And we have two unknowns. So let's make use of the other equation, that is summation force vertical equal to 0. So we have RC sine of 29.93 degrees minus the 200 kilonewton force equal to 0. And since we have a single equation with single unknown, we can directly solve for RC. There is RC sine of 29.93 degrees minus 200 equal to 0. Shift solve, we get 400.85 kilonewtons. That is our value for RC. And to solve for RD, we plug in this value to the first equation, summation force x. We can solve directly for RD. So RC is 400.85 cosine 29.93 degrees minus RD is equal to 0. And we get RD is equal to 200 kilonewtons. Oh wait, this is cosine. RD is equal to 347.39 kilonewtons. Now that we have RD and RC, we can now solve for the other unknown variables, that is RA and RB. Now that we have RC, you can take summation force horizontal to solve for RA. So taking summation force horizontal equal to 0, we have RA minus RC cosine 29.93, and we have RC, that is 400.85. Cosine of 29.93 degrees equal to 0. Therefore, RA is equal to 347.39 kilonewtons. And to solve for RB, we can make use of summation force vertical equal to 0. We have a vertical force of negative 400 kilonewton because it's going downward, so it's negative, minus RC sine of 29.93 degrees plus reaction B equal to 0. Since we have the value for RC, that is 400.85 kilonewton, we can also solve directly for RB. We have negative 400 minus RC, that is 400.85 sine of 29.93 degrees plus RB equal to 0. If solved, we get RB is equal to 600 kilonewton. Now we can solve our problem. So the reaction A is equal to 347.39. That is approximately equal to 347 kilonewtons. And for the reaction at B, we solve it, we get 600 kilonewtons. That is letter C. And that is our final answer.